This is a video walkthrough for the Practice Unit 4 Prerequisite Review. For number 1 through 21, we're evaluating each expression without using a calculator, so we need to know something about negative exponents. So when we have a base that's raised to a negative exponent, that's 1 divided by the base raised to the positive exponent, which is 1/7 for number 1. Same for number 2. 5 to the negative 2 is 1 divided by 5 squared, which is 1/25. For number 3, any number raised to the 0 power is 1. For number 4, 2 to the negative 4 is 1 divided by 2 raised to the 4th power. Remember, 2 raised to the 4th power is not 8, that's 2 times 4. 2 raised to the 4th power is 2 times 2 times 2 times 2, which is 16, so this gives us a result of 1/16. For number 5, we need to interpret what the exponent applies to correctly. An exponent applies to whatever is immediately to its left. The only thing immediately to the left of the exponent here is the 3, so that means the exponent does not apply to the negative. 3 squared is 9, and the opposite of that is negative 9. Contrast that with number 6, where what is immediately to the left of the exponent is the parentheses, so that means the entire contents of the parentheses are squared, which means this means negative 3 times negative 3, which is positive 9. Notice the different results for numbers 5 and 6. For number 7, 3 raised to the negative 2, now we have a negative exponent, and that means 1 divided by 3 squared, which is 1/9. For number 8, the exponent is not negative, the base is. So negative 2 to the 3rd power means negative 2 times negative 2 times negative 2. You don't have to write that out, but it's a negative times a negative times a negative, which gives us a negative result, negative 8. For number 9, negative 2 to the 4th power means negative 2 times negative 2 times negative 2 times negative 2, and that is 4 negatives multiplied together, so that's going to give us a positive 16. For number 10, when we have a fractional base, what you can do is you can take the reciprocal, which is 4, and raise it to the positive exponent. So 4 raised to the 3rd power is 4 times 4 times 4, which is 64. Remember, that's on your perfect cube memory list. For number 11, 5/3 raised to the negative 2nd power is 3/5 raised to the positive 2 power. That's 3/5 times 3/5, which is 9/25. For 12, 2/5 raised to the negative 3 power is the same as 5/2 raised to the positive 3. That's 5/2 times 5/2 times 5/2, which is 125/8. You can accomplish the same thing by distributing that exponent 3 to both the numerator and denominator in the division. And it'll give you the same result. 5 cubed is 125, 2 cubed is 8. For number 13, we have to follow order of operations. Exponents need to happen first. So 4 to the negative 2 is 1 divided by 4 squared. That gives us 3 times 1/16, which is 3/16. For number 14, same thing. We're going to follow order of operations. 5 squared is 25, and 3 to the negative 3 power is 1 divided by 3 to the positive 3 power. And that would give us 25 times 1/27, which is 25/27. For 15, follow order of operations. 1/5 raised to the negative 2 power is the same as its reciprocal, 5 raised to the positive 2. Exponents come first, and then the multiplication, giving us a result of 50. In 16, we need to follow order of operations, so 2 raised to the negative 3 power is 1 divided by 2 raised to the 3rd power. And 1 divided by 2 raised to the 3rd power is 1/8. If we're going to subtract, then we need a common denominator. So 8/8 minus 1/8 is 7/8. In number 17, following order of operations, exponents first. That's 1 over 4 to the 1, and 3 to the negative 2 is 1 over 3 to the second power, which is 9. So 1/4 plus 1/9. We need a common denominator. That will be 36. So now we have 9/36 plus 4/36 is 13/36. In number 18, exponents first. 3 to the negative 2 is 1/9. And then multiplication, 1 minus 4/9. And 1 is 9/9. So that gives us a final result of 5/9. In number 19, following order of operations, 2 minus 10 times 1/7, and 10 times 1/7 is 10/7. Now we need a common denominator. 2 over 1 is the same as 14 over 7. Subtracting, that gives us 4/7. For number 20, we can add the exponents, or we can just follow order of operations. Since the bases are the same, you could add the exponents, but let's just follow order of operations. 5 squared is 25. 5 to the negative 2 is 1/25. 25 times 1/25 is a number times its reciprocal, which gives 1. If we had done this by adding exponents, 2 plus negative 2 is 0, and that result would be 1 also. Number 21, let's follow order of operations. 3 to the negative 1 is 1/3, and 3 to the 4th power is 81. If we multiply 1/3 times 81, we get 81/3, which reduces to 27. Had we done this one with adding the exponents, since the bases are the same, we could have instead rewritten this as 3 to the negative 1 plus 4, which is 3 cubed, giving us a result of 27 also. For number 27, we're asked to use a property of exponents. 6 to the 10 times 6 to the negative 8 is 6 to the 10 plus negative 8. When we multiply, we add the exponents if the bases are the same, and that gives us a result of 6 squared, which is 36. For number 23, 3 to the negative 9 times 3 to the 7, since the bases are the same, we'll add the exponents, and that gives us a result of 3 to the negative 2, which is 1/9. For number 24, 17 to the 8 times 17 to the negative 8 is 17 to the 0, because 8 plus negative 8 is 0, and 17 to the 0 is 1. For number 25, when we divide like bases, we keep the base and subtract the exponents. 97 minus 100 is negative 3, so now we have 5 to the negative 3, which was 1 over 5 cubed, giving us 1/125th. For number 26, again we are dividing, so we'll keep the base and subtract the exponents, and that gives us a result of 7 squared, which is 49. For 23, we have the same base, so again we're going to subtract the exponents. 501 minus 501, and that gives us 13 to the 0 power, which is 1. We might have predicted that from the start because we had two expressions which were exactly the same and a division. So when we divide any expression by itself, the result is 1. For numbers 28 through 45, we're performing the indicated operations. And so in 28, we are adding. And when we add, we combine our like terms. 9y squared plus 9y squared is 18y squared. And negative 8 plus positive 9 is positive 1. In number 29, we are subtracting. And when we subtract, you have to remember that we are instead adding. So now I'm going to change this to adding the opposite. So I'm going to write the opposite sign for each of the terms in the expression that follows the subtraction, which we now changed to addition. So notice that we changed the subtraction to addition, and all the signs of the terms in the expression that followed that subtraction sign. Now let's combine some like terms together. 8p squared plus negative p squared is 1p squared, but 1 times p squared is p squared in simplest form. And then let's follow that with the next set of like terms. Negative 7p and positive 7p add up to 0, so we don't need to write that term. And the last set of like terms is 5 and negative 2, which added together give 3. So final result here, p squared plus 3. For 30, we are again subtracting, so I'm going to change that to 7x squared plus x plus 1 plus, and then change the sign of every term in the parentheses that follows. And now let's combine terms together. 7x squared and negative 9x squared are negative 2x squared. Positive x and positive 4x give 5x, and 1 and negative 5 added together give negative 4. In 31, we are adding, so nothing needs to be changed. All we need to do is combine our like terms. 4x squared plus 2x squared is 6x squared. 7xy and negative 1xy are positive 6xy. And negative 3y squared and negative 5y squared are negative 8y squared. In 32, I want you to notice a difference between it and the problems that preceded. There is no operation symbol in between these two sets of parentheses, which means that the implied operation is multiplication. That's going to change our approach. So we're going to use the FOIL method. Firsts, 4x times 3x is 12x squared. Outers, 4x times 2 is 8x. And inners, negative 5 times positive 3x is negative 15x. And now lasts, negative 5 times positive 2 is negative 10. Now let's combine together our like terms. 12x squared, combining the two middle terms there, negative 7x and minus 10. Same thing for number 33. The operation that's implied is multiplication. So 5x times 2x is 10x squared. And the product of the outers is 5x times y, which is 5xy. The product of the inner terms is 8y times 2x, which is positive 16xy. And the product of the last terms in each of the parentheses is 8y times y, which gives us 8y squared. Now combining like terms, 10x squared plus 21xy plus 8y squared is our final result. For number 34, this is a binomial times a trinomial. So I suggest you use a box method. It's very similar to the FOIL method, but we actually have 6 products. This helps us keep it organized. So I'm going to use a box method for multiplication, but if you like, you can just distribute each term to each term in the second parentheses. 2x plus 3 is one of our factors. The other is x squared minus x plus 2. Now let's just multiply the product of all the factors. 2x cubed, 3x squared, negative 2x squared, negative 3x, 4x, and 6. And you'll notice that when using the box method this way, very often our like terms line up in these diagonal boxes. So the end result here is 2x cubed, and combining the next set of like terms, plus x squared, combining the next set of like terms, plus x, and finally plus 6 is our last term. For number 35, the FOIL method can be used again. Product of the first 5a times 3a is 15a squared. The product of the outer terms is 5a times negative 4, which is negative 20a. The product of the inner terms is negative 2 times positive 3a, which is negative 6a. And the product of the last terms, negative 2 times negative 4, is positive 8. Combining like terms, 15a squared minus 26a plus 8. For number 36, we can again use the FOIL method. 3y times 3y is 9y squared. The product of the outers is 3y times 2, which is 6y. The product of the inners is negative 2 times 3y, which is negative 6y. And the product of the lasts is negative 2 times positive 2, which is negative 4. Combining like terms, 6y and negative 6y are opposites, so they add up to 0, meaning we don't need to write that term. So the end result is 9y squared minus 4. For number 37, we are multiplying together 3 factors. Whenever we multiply 3 factors together, you may multiply any 2 together first, and then multiply the result times the remaining factor. So x plus 3 times x minus 3 is, let's do this, see if we can do this quickly, x times x is x squared. And then the product of our outer terms would be negative 3x, and the product of our inner terms would be positive 3x. That adds up to 0, so it's not necessary to write either one of those. And finally, the product of the lasts would be 3 times negative 3, which is negative 9. Now I'm going to bring down that third factor, and now we can multiply the first result times the third factor. So again, foiling, x squared times x squared is x to the 4th power. And when we multiply the inner and the outer products, we get that same pattern that they are opposites, so they add up to 0 and don't need to be written. And then finally, the product of the last, negative 9 times positive 9, is negative 81. So the final result is x to the 4th minus 81. For number 38, we have a binomial times a trinomial. My recommendation is that we use the box method for this. So 2x plus 5, list each term from there, and list the terms of the trinomial on the other side of the box. And now multiply. 2x times 3x squared is 6x cubed. 5 times 3x squared is 15x squared. 2x times negative 4x is negative 8x. 5 times negative 4x is negative 20x. 2x times 1 is 2x. And 5 times 1 is 5. Now that we have all those partial products, we can add them together. So the first upper left corner there is 6x to the 3rd power. And on the diagonal, we have a set of like terms. And now that I look at that, I've forgotten to one of the multiplications. 2x times negative 4x was negative 8x squared. Adding those two terms together, we get 7x squared. And then next set of like terms, minus 18x, and finally plus 5, and that's our end result. For number 39, similarly, we can multiply 2 factors together first, and then get the result and multiply it by the third factor. So x plus 3 times 2x minus 1, product of the firsts is 2x squared. The product of the outers is negative x, and the inners positive 6x. That gives us positive 5x. And finally, the product of the lasts, 3 times negative 1 is negative 3. Now we're going to multiply that result times the third factor, x plus 4. Again, I suggest the box method for this. x4 are the two terms of the binomial, and the trinomial's terms are 2x squared, 5x, and negative 3. Multiplying x times each of the terms in the trinomial, 2x cubed, 5x squared, and negative 3x, multiplying 4 times each of the terms in the trinomial, 8x squared, 20x, and negative 12. Now let's add together our like terms. 2x cubed, like terms on the diagonal, that would be 13x squared, and another set of like terms on the diagonal, plus 17x, and last term, minus 12, and there's our end result. For number 40, x plus 4 squared is the same as x plus 4 times x plus 4. Make sure that you do not try to distribute that square over addition. That is not a distributive property that is valid. So just treat it as a binomial times itself. Product of the firsts is x squared. Outers and inners together are 4x and 4x, giving us 8x. And the product of the lasts is 4 times 4, which is 16. There's our end result. 6k minus 1 squared is 6k minus 1 times 6k minus 1. And that is 36k squared. That's the product of the firsts. Outers and inners are each negative 6k. That gives us a total of negative 12k. And the product of the last is negative times a negative, which is a positive 1. For number 42, we're similar kind of a setup here. We now have two variables though, 3x minus y times 3x minus y. The product of the firsts, 9x squared. Outers, negative 3xy. Inners, negative 3xy. That's a total of negative 6xy. And product of the last, negative y times negative y, is positive y squared. Notice the structure here. We start with an x squared term, and then we have a mixed term, x times y, and the last term has a variable factor of y squared. For number 43, we have to perform our multiplications here first before we perform the subtraction. So 2 times 5x is 10x. 2 times 1 is 2, and we can go ahead and distribute the negative 3 to each of the terms in the parentheses that follows, so minus 12 and plus 6x. Now just combine like terms, 16x minus 14. And 44, we have to perform the exponent first, which means rewriting this as 3x minus 5 times 3x minus 5. So let's perform that multiplication. 3x times 3x is 9x squared. Product of the outers, negative 15x. Product of the inners, negative 15x. That adds up to negative 30 times x. And negative 5 times negative 5 is 25. We still have to multiply that by the third factor, 2. So we can do that using the distributive property 18x squared minus 60x plus 50. And in 45, we need to perform the squaring first, or the exponents, order of operations. So that's 2x plus 1 times 2x plus 1. And 2x plus 1 times 2x plus 1 is 4x squared. Outers and inners each give us 2x, so that's plus 4x. And lasts give us plus 1. And now we have to change the result that we're going to subtract here to adding the opposite. So plus negative 5x plus 7. Now combine like terms, 4x squared. And then like terms 4x and negative 5x add up to negative x. And like terms 1 and 7 add up to 8.